Back in 1954, over in Osaka, Japan, Mr. Tokuzo Inoue, and I hope I pronounced that right, founded Inoue Communication Equipment Corporation, which eventually became ICOM. Here we see Tokuzo in a more recent photo. This radio was brought to me by a local ham to sell on eBay. He just wanted it sold and packaged and shipped, but I couldn't resist having a look at it and doing a little bit of work on it just to get it a little bit cleaned up before posting it to eBay. So let's go down to the bench and we'll have a look at this interesting, ancient 1970s ICOM before it was ICOM, IC-2F. Well, here it is. And over here next to it, I'll show you in a second, is the IC3P power supply. So this old radio, cosmetically, aside from some dust, looks to be in pretty good shape. No scratches on the front panel. You know, there's a few little wear and tear scratches on the sides. What's really cool with this one is we have the manual. Look at that. Operating manual, Veritronics Incorporated. And it's a, you know, very 70s, 60s, 70s looking manual. Specifications, operating instructions. You know, basically looks like typewritten pages that were printed. You know, the old manually cropped and pasted in photographs, block diagram. Nice internal pictures and such, you know, what it looks like, adjustment points and so on. And of course there's a full schematic in here. There's the power supply schematic. Where was that schematic? Oh yeah, there's all the adjustment points, all nicely labeled and pictures. And tuning instructions. We're going to go through and tune it. And a very nice fold-out schematic. You can see it's all just transistors and discrete electronics. No fancy microcontrollers here. This is a crystal controlled basic transceiver. FM. I don't know how many crystal sets are in it. He said, the ham who gave it to me to sell for him, said that it has all the local frequencies in it. And last but not least, the DF43B big honkin' Bakelite looking plastic microphone. Inoue, I-N-O-U-E is the brand name on the mic. And look at the design on that grill. Flip it over and it got that retro old radio, shortwave radio receiver look to it, you know. That's a big honkin' microphone, man. Great big huge push to talk button. It's got massive spring in there. It takes a grip, you know. You could exercise your grip working this radio. Let's take some closer looks at it. There's the front panel. Volume, squelch, and a push button. Yeah, it's a push button missing the knob for the on switch. It doesn't feel like it locks in. It almost feels like a momentary switch, which can't be right. So I'm wondering if we're going to have to do something with that to get it working. Band selector. That moves nice and smooth. Little built-in speaker here. And there's a real slight bit of a raise to that speaker grill. It's kind of instead of being flat, it kind of raises up towards the middle. So a nice little design element. And of course an S meter, microphone connector. On the back, we have power connector, which has 4 pins. There's something a little extra on the power supply. I'll show you in a moment. Model number, serial number, which is, let me read this, 4708. 4708. And a date. I can't read the month stamp, but it says 1971. 1971. Oop. well, hopefully you can't read that. One of the original owners scored his social security number into the back. I'll keep my thumb over that. An accessory connector, external speaker, and of course RF out. And crazy, I don't know why, maybe you can see that, somebody soldered the the ring on this angle connector so it can't be unscrewed. So I'm going to have to desolder that and get that off of there somehow to put the radio back. It's all dusty. You can see all the dust on the top of this thing. I'll have to clean it all up. I'll clean the controls. We'll take a look inside it in a moment. But first, here is the IC-3P power supply. Get that in the camera. We've got again, it feels like a momentary on switch. It doesn't lock in. Of course, it could just be that the switch is, dirty and needs to be cleaned up. We got a meter here that says discriminator, so that's why there's 4 pins on this power connector. They're bringing signal back from the discriminator to aid in tuning. I don't know. I would guess tuning, because you'd use that to center when you're on the station, I would think. That's odd. I wish I had well, the manual did say that it covered the 3P, so there might be a section in the manual on this on what that is for. Again, it's pretty dusty, and we've got a little problem with the adhesive on the front panel here. It's bowed out, so I might have to try to clean that up and re-glue it. On the back, made in Japan, a mysterious extra wire hanging out that somebody put some insulation on it. I don't know what that's for. And this one's got a serial number of 3855 and a date code M1970. So before I power the radio up, I'm going to take a look inside this power supply and check the filter capacitors and, make sure things are okay there. And it's got a kind of nasty 2-wire AC cord on it. I might think about replacing that with a 3-prong plug cable, or at least a cleaner one, because this one's got black nastiness all over it that was kind of eating into it and corroding. It's nasty, like it fell in some oil or something. So I'll probably replace that, just in the interest of cleaning it up. The local ham wants me to sell this for him on eBay, so I want to get it in as good and clean a shape as I possibly can. So I think the next thing I'm going to do is we're going to open up this power supply and check the capacitors and have a look inside of it. So stay tuned. Well, here's the inside of the power supply. We got some spider action going on over here. Looks like there was a spider collecting his meals inside here at one point, some dust and dirt, but otherwise it's not too bad. It's a pretty standard linear regulated supply. Big filter cap here, old style bridge rectifier there. 2 other electrolytics on the regulator board, and an old tin can style transistor there, and another one down here on the board. It's pretty simple layout. We'll look at the schematic here briefly. Now, I've already tested the capacitors with the ESR meter, and they are fine. No problems there at all. So I went ahead and powered it up, and I measured 15.8 volts coming out of it. And I thought, well, that's a bit high. So I got my tuning tool out. There's a little potentiometer down here on the regulator board, and somebody had cranked it all the way up. A lot of people did that back then. They thought more voltage means more power, and to some degree that might be true, but in a lot of cases the final section of a radio is engineered for a certain amount of output power, and you put a higher voltage in, you don't get any more power out of it, you just generate more heat because it has to dissipate that excess. Anyway, I adjusted this down to 13.6, so we're at a proper voltage. I'm going to just clean it up in here, clean all the dust and stuff out of it, and then I'm going to have to remove this button to get the front panel off. It's got a slight bow in it. I'm going to straighten that and reapply some fresh adhesive and put the panel back on nice and flat like it should be. That's pretty much all I'm going to have to do on the power supply, I think. So I'm going to get that done. Yeah, I'm still kind of undecided on this nasty, ratty power cord. It's got a transformer to isolate it, so I'm not too worried about polarization on the plug. A chassis ground might be nice to have, so I still might replace that with a 3-prong. Not sure on what the discrimination meter actually shows. Won't know until I get the radio going. The mysterious extra wire coming out of the back here is just tapped off right here. It's the this is the regulated voltage coming out, and somebody just tapped an extra wire and ran it out so that they could power something externally. So in the interest of getting this thing back to close to original, I'll probably just go ahead and pull that wire out. The other thing is they had 4 rubber grommets going through the bottom of the chassis here to provide cushioning for the bottom of the radio, and these are all rotted and falling apart, so I'm going to replace those too, so we've got fresh grommets under there. And then I think we'll be done with the power supply and we'll move on to the radio. Okay, I'm done working on the power supply. I have put a regular old 3-prong cord on it with a ground that's connected to the chassis. 4 new rubber grommets up here. I cleaned up the front panel, took the bend out of it, cleaned up the meter, and there was a rice grain light bulb above the meter which I removed, it was dead, and replaced it with an LED, which hopefully you can see that. Lights are up, looks real nice. So it's all clean and up to snuff. Now I'm turning my attention to the radio. Oh. Now we got a dirty control there. Can you hear that? Let's get more volume out of it here. It's an analog squelch. The squelch is not actually turning a circuit on and off. It's muting it out slowly. If I bring the squelch back, hear how it kind of fades out? You don't see that. You don't hear that on the new radios. All right, so we know we got an extremely bad volume control. This push button switch works. The one on the power supply, I got it to work once, but now it's stuck on again. I almost replaced that with a big ugly toggle switch, but I just don't want to take away from its look, you know? I mean, it looks original. I think it'll still sell okay with that problem. Somebody will just switch the AC line that they're plugging it into when they want to use it. I mean, this is going to end up being something a collector plays with and puts on a shelf or in a box, I'm pretty sure. So I want to keep it looking original as much as possible. I wish I did have another one of those buttons for the radio. Now the switch on the radio works. It switches in and out like it should, but what happened was, this is a screw-on knob. If I could, I'd put the knob over on the radio because I'd rather have the radio looking better than the power supply. But somebody, when their knob broke off, just used super glue. So the slug from the old knob is super glued into the shaft, and there is no way to get that out of there. It's all plastic. I'd probably break the switch trying to drill it out, and this outer shell is so thin that even if I was successful drilling that out, there wouldn't be any threads left to thread the new knob onto it. So that's unfortunate. But what do we have to do on the radio? Well, I'm going to open her up first off and see what's going on inside. We hear static, so we know it's working. But I have some obvious things I've got to do. The volume control, for sure. It's in bad shape. I've got to figure out what to do back here with this soldered on right angle. I'll have to get that off of there without damaging the SO239. Or I might end up just removing the whole SO239 and putting a new one on. I think I've got a panel mount SO239 available. So I'm going to clean the case up a bit, and then I'm going to open this guy up, and I'll turn the camera back on, and we'll take a look inside of it. Alrighty, I took the covers off the radio, and it looks like what you'd expect for a 1970s radio. All classic through-hole PC board. This receiver section here, and then here's the crystal oscillators and the crystals. And it does have some of the local repeaters, the 14676, the 14688, the 14694. That's 5.2 simplex. 14751 simplex. And 14646 simplex. So 3 simplex frequencies and 3 of the local Fort Wayne repeaters. These little capacitors down here are for pulling the oscillator frequencies of the crystals. So I might go through and check and make sure that they're all on frequency after I get done with the little bit of work I've got to do here. I did manage to get the the PL259 off the back, and I discovered why they had done what they had done. They couldn't screw it down all the way because they cross-threaded it and they screwed the threads all up on this. They're a total mess. But I've got another SO239 connector here, panel mount, so I'm going to pull this out of there, replace it. Kind of tight in there, getting to the solder points. I was looking at how to get better access to it, and the way this is put together, the radio deck in the middle here is a big square module. On the sides, you've got 4 screws on each side. This back is spot welded to this frame, so it doesn't come off. But the front panel does come loose, which is good because the other thing I've got to do is, there's one of those wheat grain light bulbs right there that's bad on the panel meter, so I'm going to replace that with a white LED. So to get going on this, I guess I'm going to have to take out these screws to free up that deck so it's floating, take the front panel loose, and just kind of tilt this chassis a little so I can get access to that SO239, so I can desolder the coax. They soldered the coax to the nut. That's bizarre. I guess back then they didn't have these little solder lugs for those things, because they actually soldered the coax to the nut on the back of that SO239. So I'll have to desolder the coax, get that SO239 swapped out, replace the meter, and then I'll go through and check the alignment. Most of the adjustments here on the cans, they're full of goo. Like they aligned them at the factory and filled them full of glue so they wouldn't shift. So if those are the IF cans, it'd be really tough to do the I/O adjustments. That's not wax. That's some kind of epoxy or something. It's like solid plastic in there. And they did it on these too. I guess they didn't want you to... Oh, they did it... There's all the inductors in there for whatever section of the radio this is. I'd have to look at the diagram to see, but they've all got that same plastic epoxy all coated up on them. Okie dokie, got her all back together. Here is that old SO239, and you can see how this nut is just covered with solder here. It was soldered to the connector there, and you can see some of that insulation's burned out. What I ended up doing was I ended up using a pencil torch, which is an attachment to my little Radio Shack butane soldering iron that generates a very small flame, about the size of a pen tip, so you can get a lot of heat in a really small area. So I ended up heating the connector here, putting the desoldering iron on there, and as I finally got the solder to melt, sucking it out a little bit at a time until I cracked it loose around the edge and I could take the nut out. And the end result is we now have a fresh SO239 connector on the back. You can see in there I got the coax soldered back in, and I've actually got a tab down there that it's soldered to now, so that's all nice and clean. On the front panel, right here, we have a white LED to replace this bulb that was over here. It was a wheat grain bulb, right into the back of the meter. I took a sandpaper and I buffed the end of the lens to diffuse the light a bit more. And fortunately, our power and ground are right there, so I was able to mount it. And it's, it's floating behind the meter, but it's not going anywhere. And it'll keep the light right on the meter where it needs to be. The other thing I did was the volume control here and the squelch. I hit them with contact cleaner and exercised them religiously. And we'll find out if that is going to be enough to take care of that problem. So let's power it up. Plug in the power supply. Here we go. Yep, that's got that solved. So I'm going through and adjusting these crystals. Now, as I mentioned before, there's a little trimmer. And I showed you, I think, a little trimmer next to each crystal. The manual here shows you which trimmers affect which crystals. I'm adjusting the transmit crystals now. I've got the probe for my frequency counter just physically resting next to the center pin of the SO239, and when I key down, you can see the frequency counter back there showing me the frequency. And so this is the last one I have to adjust, and it's channel 1. Transmit frequency should be 146.16. And 146.1604, we're pretty much dead on, but I'm going to go ahead and just go through the adjustments so you can see it happening. See if I turn that little trimmer, it drops down. We want 146.16. That's close enough for me. 146.160. It's toggling around 1 there. That's fine. We're talking about, 2.5 kilohertz FM, so that a 10 hertz difference is not much. So that's what I've been doing, just going through and adjusting each of those. Got everything pretty much spot on frequency. It's putting out plenty of power. I put it on the dummy load and the meter, and it was kicking about 10 watts, which I look at the manual. Oh yeah, RF power output 10 watts. So it's putting out what it should put out. Anyway, I've got an antenna hooked up to it now, 2-meter antenna. And I've got it switched to the only repeater I should be able to bring up, because the others are all PL tone enabled, but the 146.88 is an open repeater. So, got the mic hooked up. Let's see what happens. Hey! KB9RLW, anybody around? A K8HXJ from KB9RLW. Just testing a radio I'm working on. How's my audio?
You're coming in real good. No issues whatsoever.
Oh, well, that's good to hear. This is an old Inoue, Inoue IC-2F from 1971. It's an ICOM before ICOM was ICOM.
Yeah, wow. It would be almost like I'm standing right next to you. It's coming in crystal clear. Nothing, no static, no nothing.
Here's Kevin, by the way. I forgot to mention. So have a good trip, and 73, KB9RLW.
My name's Chris, KE8HXJ, listening.
Well, that's good. It works. And he said it sounded crystal clear, so we got good audio. So, hey. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.